Probably should have done this sooner. I did de-energize everything, but that's not to say that. Hi, this is Joel Walsman, CEO and Master Electrician of Jefferson Electric. I'm standing in our front office at our new Jefferson Electric facility. Story behind that, if you've been following our channel. And here behind me is the main switch gear. This is an interior wall of the building. It is sandwiched between office and warehouse, and the meter is actually about 30 feet on that outside wall of the building. The reason that's permissible is not because we have an exterior main disconnect, but because the conduit feeds under slab, underground, from the meter, up. See this main conduit? There are two of these 4-inch conduits up here and into our somewhat dated Murray, right, electrical gear. Now, anytime a conduit is buried under 2 inches or more of concrete, it's considered outside. It is not inside the building. If you recall, panels and gear inside the building are required to have an exterior main disconnect if they are more than a nominal distance inside the building. In some jurisdictions, if they are inside the building at all, regardless of distance. In this case, these are located at the nearest point of entry, so this is a permissible installation in our jurisdiction. Now, what I'm going to do here is I'm going to access this panel, and I'm going to show you what Jefferson Electric does for a standard panel inspection. I'm not going to touch the mains on the line side of that breaker because that would require me to organize a utility disconnect at the exterior transformer. Kind of crazy, right? But that's the case that we're in here. So I'll show you everything else, I'll give you pricing, and I will give you a good sense how to evaluate an electrical panel and an adder that you can put on your services to help give a customer peace of mind. Now, one more thing. What I tell customers is this. My talk track, it sounds like this. Hey Betsy, so I'm gonna be inside your main electrical panel and I'm gonna take a look at absolutely everything. But there are some things I'm not gonna do. I'm not gonna torque everything. That was the responsibility of the prior electrician. I'm not gonna do draft stopping, anti-corrosion, anti-oxidation. I'm just gonna give you a quick electrical inspection. But what I'd like to ask you to consider is, go ahead and pay me another $142, and I will take care of everything and give it a good once-over in the electrical panel. If I find something that's going to be somewhat time-consuming to correct, like replacing a breaker or adding a ground bar, now that would be an extra charge, and I'll let you know about that before I add it. But I'd really like everything in here to be absolutely just right. I'm the last person to have my hands on here, and you know I'm gonna have some sense of responsibility. If you call me in 6 months and tell me that something's failed, what if we just go ahead and spend a little extra time and take care of that right now? How does that sound to you? Usually Betsy looks at me and she says, $142, and you'll check out everything in there, and then you'll take responsibility for everything in there as well. Say, absolutely. And Betsy says, absolutely. Here we go. Woo! I really don't know what I'm going to find here. I do know that there's plenty of poorly performed electrical work in this building. It's time for an electrician to take some responsibility around here. Woo! And I do know that some of this is somewhat dated. So my battery died, but I got just enough information on my $300 Klein thermal scanner. Now you can spend $7 or $8 grand on a FLIR, but this little baby is shock resistant, it's compact, it fits in your tool bag, and our goal for our electricians is to scan every panel when you have the cover off. Every time. This is a valuable source of information. At this point, we've got no hot spots in this panel, and we've got a link to this product in the description below. This is our standard thermal scanner at Jefferson Electric. So before I start getting my fingers in the panel and turn off power, I'm going to take a good visual inspection. I'm looking for corrosion. Corrosion exhibits itself in the form of white, chalky, powder, dust, anything that's not true to its original color. And so actually what you're seeing right here is pretty favorably colored looking main connections. I don't see any source of water infiltration above the panel. For instance, if I had staining on the plywood, that would make me a little bit more suspicious. If there was excessive rust on the panel enclosure, that would make me suspicious. One plus side of having this buried inside the building is that it's not been exposed to outside weather conditions, temperature fluctuations. It's not been, if it even, let's say this panel is about 30 years old, if it had been mounted to concrete block on the exterior of a building, that would be a definite source of moisture. Most block is not going to have a masonry sealer on the outside. It is porous and it's going to absorb that moisture through and corrode the back of my panel. The panel is enamel coated, so it'd take time, but 30 years is sufficient amount of time for that corrosion to then work its way into the integrity of the panel. Actually, right now, the overall first glance, pretty positive. Pretty positive. I'm not seeing any discoloration, no water staining, no rust, no corrosion. It's pretty clean for its age. This is a Square D QO snap-in, just like this. Got some breakers I found sitting aside there. So this is the supporting side. There's no conductivity that happens there. And then this is the conducting side. This is a 2-pole breaker. Even though it has a half-sized handle, you know it's a 2-pole because it's got 2 connections. And that half-size handle is kind of just unique to the Square D QO brand. If this is an industrial application, the process is going to be different. I have already notified the people in the office and the warehouse that I'm going to be shutting off power to this panel. Not all the breakers are labeled at this point, only a few of them. But if this is an industrial application, you've got to be very careful about turning off breakers and what sequence you turn off and back on breakers. You've got to be mindful of the fact that there could be an incredible load on this panel. The load right now is pretty minimal. In fact, I'm going to check that before I turn off breakers just to see what kind of load I'm disconnecting. So we're going to use Klein amp meter. We're going to set it to AC amperage, slip it in there. Holy cow. Less than an amp. There's almost nothing on this. 6 amps. Almost 7. Very minimal utilization on this panel. So we're not disconnecting under load. When you disconnect under load, you can get quite the boom and quite the flash. Now, it's kind of like slamming on your brakes when you're on the interstate. Yes, absolutely you can do that. That's fully permissible. The brakes are made for that kind of emergency situation. But if you made a habit of driving your car like that, you bet your bottom dollar you're going to warp your rotors, you're going to wear out your brakes, you're going to put stress on your vehicle that it was not intended for habitual use. So when you sequence off and back on your breakers, understand the loads that are present, which in this case, almost nothing. This is a 200 amp, 3-phase main breaker panel on a high leg Delta system. It's very lightly loaded. So I'm not too worried about the sequence. We don't have any industrial automation or manufacturing equipment that's got to be taken into consideration. If you're at home, the considerations are de-escalated, are minimal. If you are in a commercial setting, if you're in an industrial setting, that's when things start to escalate, and you really probably shouldn't be doing this unless you've got a certification under your belt. All right, so take a look at our panel there. It's very, very cool. It is a relative scale. So if we pan over here and we catch, look at that. A lot of things that are hotter in this room. But our panel with 7 amps per phase or less is very, very cool, very mundane. That's one of the most boring panel inspections I've ever seen right there. So back to corrosion real quick. A couple of instances. The Statue of Liberty was not intended to be green. It's a copper statue, but you see that color change to green. That is one example of the tarnish that happens over time to copper conductors when they're exposed to weather. If your copper conductors are not bright orange gold, that's a problem. That's an evidence of that potentially. You probably want to unland the conductors, clean them up, get them back to bright, and they will get back to bright with a wire brush and reinsert and torque them down. The other evidence that you might be familiar with is like batteries in a kid's toy that have been there for 3 years. You open it up and there's all that white chalky flaky. That's also a bad sign. It's a different type of corrosion, but it looks very similar in nature to what you could find inside your main panel. All right, let's flip some power off here. Now, one thing I'm noting is there's a lot of dust. This place used to be a cabinet shop. We've got some open knockouts in the top of this panel, so I think just dust is filtered from the warehouse on the other side and into this panel. So I'm going to want to use compressed air to blow that out. Manufacturers also have a recommendation for how often the breakers are cycled, and that is generally about every 6 months, and that's just turning them off and back on again. So that's a recommended function. Here goes the main. I just look away. You just never know, you know? Nobody wants to get their face fried off. There's not enough fault current available here to probably roast me. Okay, breakers are off. I'm gonna start popping them out of their slots. I'm watching out for a couple different things here. One is if a breaker pops out too easily, that's a concern. That to me tells me that, and they are thankfully in there pretty snug so far. I'm gonna use my channel locks without damaging the breaker housing. If they're too sloppy, that tells me that I've got a weak connection. And when the breaker goes under a heavier load, that point of connection that's too weak, it's going to translate into resistance. Resistance means heat, and heat means potential for fire and failure. Low heat means slow failure over time. High heat means fire. Look at that, way too much dust. Just blow it off, wipe it off, step at a time here. I don't tend to be an alarmist, so if you feel like freaking out in the comment section, by all means, enjoy. I'm sure that there are many old timers out there that have something that I should learn. So please do tell me. Pop these out one at a time, and we're just gonna run on down here, taking a look at everything. Sometimes breakers have been jerry-rigged. Not so much in this panel type, but in other panel types have been jerry-rigged to be inserted into panels which they are not rated for. So checking the backside of breakers, sometimes you'll see that material has been removed. It was intentionally there to prevent the insertion of non-compliant, non-compatible breakers, and they've been field dressed or field modified in order to accomplish that task. Whew. All right, got a lot of things going on here. Take it step at a time, but let me give you this little tip. I mentioned that a panel inspection, we charge $141.50. And it's not that the calculation is that precise, it's that what I'm attempting to communicate to customers is I was very thoughtful about how I put this together. And we collaborated on it, we came up with a price where there's gonna be a high value to the customer and a good margin for Jefferson Electric. I highly recommend that you insert panel inspections for your sake, for the customer's sake, and for your bottom line sake into your product and service offerings. $142 generated easily without materials in under 30 minutes. That's a good gig, and that's a nice little add-on. One thing that's real important, I mentioned high leg delta. What that means is this stab on the bus right here and this red colored incoming phase, A, B, C phase, is 240 volts with reference to ground. That means if I take a 120 volt appliance like this breaker and I insert it right there on that stinger phase, remember this panel is de-energized, on that stinger phase, I'm gonna have 240 volts, twice the required and compatible voltage. And so I'm probably, if I make a mistake and accidentally move these breakers up in this situation, I'm gonna blow somebody's computer right off the desk. Like literally, it will catch fire and fail dramatically. I've doubled the voltage. If something has a voltage rating and the voltage is under-delivered, it could catch fire, but it's more likely that it's just not going to perform or not going to perform well. If the voltage is too high and way outside of the rating, in this case, double the voltage, it will fail in ultra dramatic fashion. Something will catch fire. All right, so that's it for the breakers. Now, one thing to mind is you really gotta apply some significant force to get them fully snapped back in there. There can almost be a teaser where that prong has, it's connected with the stab on the bus, but it's not fully seated, and you've just got to be certain. Another thing, I've got my Corrosion X out here, and this is something that I personally like to do. If I'm trying to mitigate an issue in a panel where there is corrosion, this Corrosion X, it kills rust and corrosion, safe on electronics, world's greatest. It's like 10 bucks or less for a can. It's not WD-40, but it is probably comparable. If I've got a corrosion or rust issue that I'm trying to mitigate, I would spray that on the guilty parties only in the de-energized state, and only if I'm trying to mitigate an issue. In this case, I don't have any signs of rust and corrosion despite the age of the panel. Awesome. I'm not going to introduce an outside and foreign source unless it's the better alternative to an issue that's going downhill. All right, next, I'm going to be mindful of the torque setting of each one of these breakers and the terminal bars on left and right. And I'm going to go ahead and torque things down. I'm going to give them a tug test first. Then I'm going to torque them to the proper setting, and that is going to be found on the breaker itself. Let's see if I can identify. I'm going to do one more precaution. This is a big facility, a lot of hands in it over time. Probably should have done this sooner. I did de-energize everything, but that's not to say that something couldn't be backfed. And in that case, I would be coming in contact with an energized source and an improperly insulated tool. All right, I don't think we have any issues here. Whew, got about a half turn on that, or a bit more before it torqued. Wiring connections do come loose over time, believe it or not. Oh my holy moly. It's like a turn and a half. Whew, uh-oh. That terminal is giving evidence of stripping out. Warehouse. Special. Look at that. It did not get to full torque before it started to spin. I'm going to have to turn that one into the customer. Quote, replacement of a 3-pole 20 amp QL breaker. We'll probably be in it for 125 bucks, but at least we found it now. Before, we had a separate service call, troubleshooting, plus the cost of replacement, and we could have been in it for $300-400, and the inconvenience of a shutdown when the customer's trying to be in full operation. So it's cheaper to find it now. All right, we're going to adjust our torque to 50 inch-pounds for that 100 amp breaker. There it is, on the money. By the way, torque equipment does need to be recalibrated periodically. Whew, I got more than a full revolution on that. That's how loose it was. And it could be, it was torqued perfectly in the original installation, and this is literally just the impact of time. All right, now we're going to torque these terminals. I need to find a data sheet here and see what we're going for. All right, branch neutral and equipment ground bar. Oh, 10 to 14 gauge copper. Torque in inch-pounds. If it's a large screw, it's 35 inch-pounds. If it's a small screw, it's 10 inch-pounds. Man, 10 is not a lot. I'm a little surprised. I would have guessed at least 15. All right, bringing it down to 10. Now in that case, because that's easy to achieve, it's probably likely that they're all over torqued. This has got a pretty fat handle. Fat handle converts to higher torque from the user, but a standard screwdriver like this, look at the contrast, they probably still were easily able to achieve 10 inch-pounds of torque. So if I had to guess, not a lot of these are going to move much. Yep, look at that. Everything's already over. I'm gonna make the decision not to loosen it up I don't know if that's right or not. I'd love to have your comments below. But I think that's the lesser of evils at this point. I think that is. Like I said, these main terminals are energized. I'm not going to touch them. In relationship to that, I'm not going to touch this main neutral either. Giving it a wiggle, there doesn't seem to be any kind of movement. If you see those strands moving dramatically when you're wiggling the conductor, no, that's a problem sign, because they should be mashed down right there, and you really shouldn't get any movement on the opposite side of the terminal. Another thing I'm looking for here is grounds and neutrals, common or separate. Take a look right here, right there. That strap goes behind this equipment and re-emerges right here and connects terminal bars 1, 2, 3, and 4. I am interested whether those screws are snug. And yes, these Phillips screws are what's connecting the terminal bars to that strap and to this lug. The other thing I'm looking for is a bonding jumper right there, that big green flathead that connects terminal bars to the cabinet. And because this is the first means of disconnect, grounds and neutrals are to be common and are to be bonded to the cabinet, so that looks really good. We don't have any double tapping or other code violations taking place there. We've eliminated a lot of the dust. We're going to blow this out down here. Put in a 1/2-inch KO closer up there. Check down the sides for any other evidence of openings. I do see a ground here which goes down to a copper ground rod there. That's number 6 solid. That's the largest size that needs to be run to a grounding electrode, unless by AHJ or engineering supervision stated otherwise. So a couple minor fixes: pop the cover back on, re-energize power, give it, actually reverse that. I like to re-energize power, give it a quick voltage test all the way up, because what can happen is you turn one of these breakers off. It's compromised internally because of moisture or just a manufacturing defect or heavy use over time, whatever. You turn it back on and it appears that everything should be working. It hasn't tripped. But what you find is one of the poles inside the breaker did not engage for whatever reason. And now you've got a leg that's dead on a piece of equipment because this breaker has been sitting under strain, and has possibly been sitting for 20, 30, 40 years under strain, and it's never been exercised once. So when you go to move something after 40 years that's got fine parts and they need to snap into place and engage just right, I've had failure, and it's not the least bit uncommon. So I'm going to re-energize with the panel cover on. I'm going to check voltage to ground on each one of these, and we're going to make sure that everything works and is getting output. Then if there's another issue, it's not in the panel. I've got confidence, everything in here, perfect. All right, watch out, here goes. Sounded pretty good. All right, just checking step by step. Main breaker looks good. C phase is hovering at 207. Got nothing there. Whenever you measure C phase to C phase or same phase to same phase, you should get 0 volts or a nominal 0. It may hover at like 1.6 or some random reading. That's randomness, that's not relevant. So that is C phase. Every third phase, so let's just walk through this. A phase, B phase, C phase. These top two, A. Second two, B. Third two, C. And then that pattern repeats itself all the way down the stabs of the bus. So if I go A phase, skip 3, A phase, skip 3, A phase, skip 3, that's my A, B, C, A, B, C, A, B, C, A, B, C. All right, so it looks like I'm in good shape how I've got the breakers lined up. Before I energize them and risk blowing something, I'm gonna leave the spare breakers in the off position. I do itemize separately a complete panel labeling from a complete panel inspection. Labeling a panel in a facility like this can be very labor intensive. You could have an electrician and a helper on the job for half a day even with the right equipment, that might be a $1,000 invoice. Not an exaggeration. All right, let's turn these things on and look for and feel. Now, when you turn a breaker on, you're gonna feel what's happening inside. You're gonna feel the vibration, and you're gonna get a sense for what that should feel like over time. And if you get something that's real flat and dull, and there's not that click and snap, that's probably a trouble sign. Now, I'm not surprised. We've got a good quality breaker here, and we've got a location that's not suffering from any effects of humidity or moisture. So I'm not the least bit surprised that everything looked good, felt good. Less than 30 minutes, $142, no materials other than that KO closer. I'm gonna do that complimentary, blow this out. I've got confidence. I've just secured a change order on this breaker because top terminal is legitimately failed, stripped. That's just a problem down the road. It's not like it's gonna blow up tomorrow, but it's gonna be a problem at some point. So I recommend that for whatever business you're in, look for ways to add value. I can't tell you how often a customer has said, I'm so glad that you offered me that service. I do want to do everything I can to protect my family. Safety is important to me and my husband. Please, thank you. If you've enjoyed this video, subscribe to Electric Pro Academy for real skills to make real money.